A manually adjusted AC source can become the weakest link in an otherwise automated test station. If voltage, frequency, dwell time, or transition behavior depends on operator judgment, repeatability suffers, and so does confidence in every pass or fail decision. A basic variable AC power supply is often the right tool for exploratory work. Engineers can raise or lower the output, observe device behavior, troubleshoot faults, and perform straightforward functional checks. This direct control is useful for prototypes, repair diagnostics, classroom demonstrations, and service benches where the objective is learning rather than formal screening. The limitations appear when testing becomes routine. Manual knobs, handwritten readings, and separate meters can introduce variation between operators. Settings may differ slightly, dwell periods may be inconsistent, and transient events may be missed. If a product later fails, the team may be unable to reconstruct the exact AC conditions applied during the original check. A programmable AC power source addresses the process, not merely the output. Depending on the model, it may provide presets, controlled sequences, remote interfaces, waveform functions, event simulation, and integration with test software. The term programmable alone is not enough, however. Buyers must confirm the actual functions, command behavior, timing control, and status reporting offered by the equipment. Repeatability is the central advantage. Voltage, frequency, dwell time, transitions, and acceptance conditions can be applied consistently across devices and operators. In an automated test environment, this links the source directly to the test script and strengthens the evidence chain. Integration requires more than remote control. Procurement teams should verify interface compatibility, command documentation, timing precision, fault reporting, remote lockout behavior, and recovery after alarms. A source that accepts commands but provides weak status feedback can still create substantial operational risk. Programmable sequences also allow engineers to evaluate behavior beyond a convenient static condition. Controlled line changes, voltage drops, frequency changes, startup conditions, and repeated power transitions may reveal reset behavior, power supply margin, thermal response, firmware timing problems, or abnormal load behavior. The appropriate source depends on test consequence. For low-risk exploratory checks with predictable loads, a basic variable supply may be sufficient, provided capacity margin, protection, and operating procedures are defined. Recurring validation across products or markets usually benefits from presets and clear measurement visibility. Production quality assurance, reliability screening, warranty-sensitive work, and automated pass-or-fail stations require stronger repeatability, status feedback, overload handling, and documented procedures. When results affect shipment release, acceptance limits, calibration practices, operator permissions, and data retention also become important. Protection remains essential in either case. Programmable control does not replace overload, overcurrent, overtemperature, or short-circuit protection. Automated stations must also define how faults are communicated to software, whether output is disabled, and whether the device under test should be retested, rejected, or inspected. Bench-class products such as the Matrix APS 4000 family illustrate the role of adjustable output combined with visible measurements. Such equipment can suit manual research, service, education, and small batch inspection. More advanced applications may require other source families with higher capacity, broader operating ranges, or programmable test functions. The key is to evaluate the portfolio against the process rather than treating one product class as a universal answer. Before purchasing, define the required voltage and frequency ranges, dwell periods, transitions, startup behavior, evidence needs, communication interfaces, calibration expectations, and future automation plans. A simpler source avoids unnecessary complexity on a manual bench. A programmable source becomes necessary when repeatability, integration, and defensible test records are part of the result.